Hello and welcome back to the channel. This is Abhinav. So in this video we are going to discuss about the problem number A and B of Codeforces Educational Round 133. So the round was really difficult and the first two problems were very easy and the difficulty of the third problem was very high from the related to the first two problems. So overall the round was a bit difficult. Okay. If we talk about the first two problems, so yeah, you can say that the first two problems are easy. As you can see the submissions, they have more than 10,000 submissions both the problems, so they are easy. I am also not able to solve more than two problems. I was just able to solve the first two problems, and also I started the contest a bit late, some 7-8 minutes late, so that is why also my rank is also down for this contest. Okay, no problem. Let's discuss the problem number A first. So in the problem number A, you are given with the coordinate line. So where there is a point 0. So your goal is to reach the point n. So basically there is a number n given to you. Your goal is to reach there. The thing is that you can move by 2 or by 1 to the left or to the right. Okay. If your current coordinate is x, means either you can move 2 steps right or 3 steps right, or 2 steps left or 3 steps left. This is how you can move, and you have to reach a point n. So you have to tell the minimum distance, okay, minimum number of moves, okay, so that you can reach that point. So if we will just see one thing, first there is a corner case, because the value of n is always positive. The value of n is always greater than 0. That is the case given to you, okay, that the value of n is always greater than 0. So if it is greater than 0, there is no need to move leftward. We will always move rightwards, because if this is a coordinate line, let's say this is the point 0. So if value of n is positive, that means n will always lie at the right side. So there is no need to move at the left side of that 0. But there is one corner case which is 1. If we have to move to the point number 1, in that case we have to first move, because we cannot move directly to 1. In that case, there are different cases how you can move to 1. The first case is that you can first move to 3 by taking 3 times right and then 2 times left, so it will reach 1. Or either you can take first 2 times left, you will reach to -2, and then 3 times right. These are 2 ways. So basically in both the way you are taking 2 steps, minimum 2 steps are required. So to reach point 1, in that case only there is a case that you have to first move right then left or left then right. Otherwise there is no need to move left. All the points are present at the right side only. Okay. For example, let's say that you have to move at the point n. Okay, there is a point n. So obviously because we want our moves to be minimum, so we want कि kam se kam moves le. Okay. So we will try that we will take 3 moves at a time. 3 at a time. Okay. So what we will do that we will take 3 moves until we will not cross n. For example, if n modulus 3 is equal to 0, in that case the answer will be normally n by 3. Means normally we can take n by 3 times 3 moves and we can reach the point. For example, if n is 6, so we can take 2 times 3 moves. We will reach 6. For example, n is 7. In that case, what we will do? In that case, yeah, from 0, first we will move 3. Then from 3 we can move 3. But then from 3 we can't move to 7 directly. Either we can move to 8 or we can move to 9. So in that case, what we will do? In that case, maybe you will think that 2 is to move from, okay, so here it will be 6. Means from 0 to 3, then from 3 to 6. In this case, what we will do, when the value of n modulus 1 is, n modulus 3 is 1. In that case, what we will do? In that case, last 2 steps will be 2 and 2. So after this 3, you will take 2 and 2. So that 3 plus 2 will be 5 and 5 plus 2 will be 7. This is how we will do. And if the case is that n modulus 3 is 2, in that case also there is a very simple case that, yeah, after taking 3 n by 3 times, you will just take one more 2. For example, if you have to move to 8, then you will first take 3, then take 3, then take 2. This is the way how you can do. So basically the number of moves you are making are something like this. If I will write a generalized formula, so moves are something like this. This is the formula which you have to derive. It is something like this. If we have to reach point n, then n plus 2 by 3 are the number of moves which we have to take. Okay. Only this is the corner case when the value of n is 1. In that case, 2 moves have been taken. Otherwise, n plus 2 by 3 moves has to be taken. Because obviously n by 3 moves are taken. N by 3 moves are taken always. Okay, that is always the case. And there is one more case. If the value of n mod 3, because listen, if the value of n mod 3 is 0, in that case the answer will be just n by 3. If the value of, sorry, I hope that you are not visible, this is not visible, fine. If the value of n mod 3 is 1, let's say, is 1, in that case it will be n by 3 plus 1. And also when it is 2, then also it is n by 3 plus 2. You can check. Because जब ये 2 होगा तो सिंपली हम लोग एक 2 स्टेप बढ़ा देंगे, भाई 3 के स्टेप लेंगे, लास्ट में एक 2 स्टेप ले लेंगे. और जब ये 1 होगा तो क्या करेंगे, तो आखिरी के 2 स्टेप्स को 2 का कर देंगे. Just like here what you are doing. Okay, this is the problem number 8. I hope you have got it. If you will just check the statement, okay, so you can see that if you just move towards the code part, I think the contest is going to be over. Yeah, so I will just upload the video of the contest. Okay, so here you can see that what I have done is that I have simply taken, if n is 1, then I have outputted 2, otherwise I have first added 2, then divided by 3. A normal case is there, okay? N plus 2 by 3, that's the formula. Now let's move towards the problem number B. The problem number B is that we have permutation n and sequence of integers from 1 to n such that each integer appears in exactly 1. So basically you are given the permutation and you have to create some more sequence of permutations, subsequence of permutations, okay, such that you have to take that there is a fixedness of the permutation. Fixedness is the number of positions such that the index of the number and the element should be equal. If the index and the element in that permutation is equal, so that is the fixedness of that permutation. Fine. तो हमें क्या करना है, हमें कुछ sequence of permutation बनाने हैं, build करने हैं. We have to know how many sequences we can build, and we have to also output that sequence. In case of multiple answers, we can just print any of them. Okay. So there is a very clear observation. Let's take an example. Okay, let's take an example that the value of n is. Okay, just a minute. That the value of n is 3. Okay, fine. So in case when the value of n will be 3, in that case there will be some case key when it is 3. Okay, when it is 3. So the case is key, we will take 1, we will take 2, we will take 3. Okay, we will take 3. Then the another will be, we want our fixedness to be strictly less than. We want our fixedness to be strictly less than, Fine, here you can see the fixedness of permutation I1 AI is strictly lower than the fixedness of I minus 1. So when this is the original permutation, so fixedness of this will be equal to the number of elements in, which is 3. This is its fixedness. Okay, fine. But now what we will do, in the first case we will reverse the first 2 elements. This will be reversed. So it will be 2, 1, 3. Okay, 2, 1, 3. Now the fixedness is just 1. You can see this element is only fixed. So fixedness is just 1. Fine. Now we will increase the fixedness, so it will become 0. How? We will just reverse these two things. It will be 2, 3, 1. Okay. So it is auto erase is there. So maybe let me just change. Okay. Sorry, the white version was not visible. So I am saying, let me just repeat the answer. Let me just repeat the thing. what I was trying to explain. Okay, I was saying that let's take example of 4, that the value of n is 4. Okay, let's take this example. So the array is 1 2 3 4. Okay, so here the fixedness is 4. This is the fixedness of this array. The first, obviously we have to reverse, we have to swap elements now. So let's swap the first two elements. It will be 2 1 3 4. So after the first swap operation, the fixedness will directly become 2 less than the original fixedness. So it will be 2. You can see here only 2 elements are fixed. After that we have to decrease the fixedness by 1 only, because we have to decrease it. We want it strictly lesser, so obviously we have to decrease it. There is no case कि वो fixedness बढ़ जाए या वो fixedness वही रहे. हमें decrease तो करनी पड़ेगी, because it is written that we have to strictly decrease it. Right? So we will try कि 2 से 1 हो जाए, फिर 1 से 0 हो जाए. हम लोग अगर चाहे तो हम लोग इन दोनों को स्वैप कर देना, तो ये 2 1 4 3 बन जाएगा. तो देखोगे स्टेटमेंट सीधे 0 हो जाएगी. स्टेटमेंट इज 0 नाउ, बट वी वांट maximum such permutations. Okay, in this case only 3 permutations will be there. So what we will do is fine. We will do it in another way. कि भाई पहले 1 था, मतलब 1 2 3 4. After 1 2 3 4 what we will try that it is 1 2 3 4. Okay, after 1 2 3 4 we will try for कि और अच्छे से हो जाए. Fine. So we will just swap the first two elements in the first pass. In the first pass, the first two elements will be swapped. Okay, and in the later pass we will just swap the ongoing elements. For example, the first array is this. First we have swapped the first two elements. Okay, so it will be 2 1 3 4. So here the fixedness was 4. Okay, here the fixedness was 4. Here the fixedness is 2. Now we will swap these two elements. Okay, so it is 2 1 sorry, it is 2 3 1 4. Okay, here the fixedness is 1 only. Here fixedness was 4, here 2, here 1, and then we will want our fixedness to be 0. So we will swap these two elements. Okay, so this is how we are doing. So basically the number of permutations will be equal to the number of elements in the permutation. Okay, I don't think that my whiteboard is not working well, so sorry, but it is quite easy explanation, I hope. Okay, so here you can see that I have first created the permutation, then first I have printed the original permutation, and I have also printed the value n, because number of permutations will be equal to n, and then I am just swapping the adjacent element 1 by 1. Okay, and minus 1 times, and then this is the, so I will just share the link to this in the description box. You can just check it. I hope that video is helpful. Thank you.